Hi everyone, let's solve this problem. House robber. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So, these are the four houses they have, and each house has this, like, ith index will have the I value, array of I value, or nums of I money in their house. And we cannot rob these two houses at the same time and these two houses at the same time because they are adjacent. So now let's understand how we can optimize it. We are planning to maximize the amount of money we are robbing. So there are only two possibilities. One is take it, the other one is do not take it. If I take it, I cannot rob this element here, right? Because I have already taken this. If I take this, there will be a security alarm. So I have my answer in these two, the rest of the space. Let's say I don't take it. In this case, I have this as my space to take the values from. Now let's try to understand how we can optimize it. At this particular position, I just have one house, so I'll take this value. And at this, when we have two places, I can either take this or take this. I cannot take both the values, so I will choose whatever is the maximum. The maximum of these two is 2. Now when I am at this position, either I can take this and this or just 2. So there are two possibilities here. One is 3 plus 1, one is 2. 4 will be 3 plus 1, right? So which is the maximum? 4. So obviously I will choose this. It is coming from 3 plus 1. And then in this entire space, when I am here, either if I choose this value, I will have to choose the value at this, nothing but 1 plus 2, 3. But if I don't choose it, I can just take the previous value, which is 4, which is nothing but the maximum of 1 plus 2. Like if I choose it, it is 1 plus 2. If I don't choose it, it is 4. So I'm going to not going to choose this element. So this is how it works. So if you take at ith position, if I am at this particular position, ith position, if I take it, I am going to include my nums of I. And what am I going to do? I am going to take the answer, wherever answer I am storing. Let's consider I am storing my answer in DP. Then I am going to take I minus. If I am taking it, it will be I minus 2. If I minus 1, I minus 2. So it will be I minus 1. Or if I am not taking it, I can directly take the answer of I minus 1. And among this, I am going to choose the max of it and I'll update my answer. And my final answer would be there in the last index of the array. So now let's try to code it up. So let's say if nums.length is equals to 0, that means we just have no houses, so we will just return 0. If nums of length is equals to 1, then we will return nums of 0, the same element. If not, then we will declare a dp array, which is an array of nums.length, and initially we will fill it all of them with 0, and dp of 0 will be nothing but nums of 0. and dp of 1 will be Math.max of either nums of max of nums of 0 or nums of 1, one of them. Initially whenever we were looking at 1 2 also, we chose 2 because it is maximum of 1 comma 2, and then we will iterate I from 2, I less than dp dot length I plus plus, and dp of I is nothing but we are taking max of, if we are taking that element, nums of I plus dp of I minus 2 and dp of, if I am not taking that element, I will just take the answer of previous element, and my answer will be in dp of nums dot length, last index basically nums dot length minus 1. So this is how it works. And also we are iterating from 2 because both the cases are already covered, and I minus 2, like if I have to subtract 2 minus 2, it will be 0. To even avoid the bounds, we are kind of starting at 2. So now let's run it, submit it. Cool. So let's now try to understand this. The time complexity of this is nothing but big O of n, considering n is the length of the nums array, and the space complexity of it would be big O of n because we are creating a dp array of length n. So there is also a better solution than this to optimize the space, where we can go from big O of n to big O of 1. So you can try it out and you can let me know. I hope the solution which I have explained is clear. Thank you.